Hello and welcome to this episode of SPSS one-on-one series with the word analytics. Today we look at extended Cox PH model in SPSS. What is extended Cox regression? It is an extension of the standard Cox model for handling violations of the proportional hazards assumption in survival analysis. The extended Cox model allows you to include time-dependent covariates, which means you can model the effect of variables that change over time or violate the pH assumption. So this means that before you use this model, ensure that you have already checked for the proportional hazards assumptions violations, which are commonly done using plots or time covariate interaction terms. We have a separate video on how to assess for the assumptions of the Cox Proportional Hazards Model in SPSS. The link is in the description of this video. Be sure to check it out. So let's jump onto the PC and see how it's done. So this is our data set. Remember, extended Cox model is a part of the procedures for analyzing time to event or survival data. So here, the outcome here is time to event, and then we have the event itself, whether it has happened or it hasn't happened, which we always call censored. Then we also have here other formal variables that we want to use to assess whether there is a relationship between them and the survival time. In this data set, we have a variable called age, which we think it is the effect of age on survival time changes over time. So it violates the assumptions of proportional hazards, which requires that hazard ratio is constant over time. Like I said, for you to conclude that this variable violates the assumptions, you have to check for it. So how do we run an extended Cox regression in SPSS? Simply go to Analyze, then you go to Survival, and then you select Cox with time-dependent covariates. Click on it. In this dialog box, we have an expression for time, which we shall put here. A time covariate is simply a product term of time and that variable. So we have to put here that expression of time times the variable that we think changes over time. It is effect on survival changes over time. So we are going to put here age. And then after setting this expression, click on model to set up your model. In this, we are going to specify which one is the time to event variable, which is our time in months. Then which one is the variable indicating status, whether the event happened or did not happen. So we put it here, and we define which coding exactly shows that an event has happened. Put here a 1. It could be a range of values, or it could be a list of values. So you click continue, and then we put all our explanatory variables, including the time covariate, in the block of variables here. So we are going to have the time covariate that we've created between time and age. Then the rest of the variables are going to also be pushed there. And we specify which ones are categorical. Then we specify which ones are categorical. And in this case, group is categorical, sex is categorical, and then smoking status. But we want to use the first group as the reference category. So click on first and then change. Ensure that all of them are selected, otherwise you may change only one. So first and change until you see that they all have the word first against them. Then click continue. Under options, we are going to select we are going to ask for confidence interval for exponents of beta, and then you click continue. Then click OK, and here is our output. We have the case processing summary showing you the events, those that are censored, total, any missing. Then we have the dummy variables created here for the categorical variables. And we have the omnibus test of model coefficients, which tests how good the goodness of fit for your model. If you have a statistically significant value like this, it shows that adding variables in this model significantly improved the model compared to the null model. Then we have beta, which shows basically changes in the natural log of hazard ratio and their significance. Those less than 0.05 show that they are statistically significant. And then when you look at our time covariate, it confirms what we said about this variable of age varying over time, showing you that this variable age, it has a time dependence, so it violates the assumptions of the standard Cox Proportional Hazards Model. So while they are not interpreted directly, but usually negative values show that there is a negative relationship with survival time, whereas positive indicates that there is a positive relationship of that variable with survival time. Of interest for us here are the exponents of beta, which are the hazard ratios. And these ones, hazard ratios of 1 indicates that there is no influence of that variable on survival time. If it is above 1, it shows that participants in one group have a higher hazard compared to those in the comparison group. Or if it is a numerical variable, it shows that a unit increase in that variable is associated with a higher hazard. We have a previous video about interpretation of results of a Cox Proportional Hazards Model. I highly recommend that you go and check on it, where we provide the details and how to interpret with examples and how to present results of your Cox regression model in SPSS for your research output. The link to that video is in the description of this video, so be sure to check it out. So that's how to run an extended Cox Proportional Hazards Model when your data violates the assumptions of the standard Cox. In our next episode, we shall be looking at another concept, another type of analysis called factor analysis. So consider liking and subscribing to our channel so that you don't miss out any of our episodes. See you in the next video.